This is going to be like a Ken Burns documentary. My kid is practicing viola back there. Welcome to an episode of Help Me Ruin This $200 dynamo light. This is a Busch and Mueller Luxos U. I love these lights because they are bright. They have a really wide field of view. They run from a dynamo hub. They also have a very convenient switch right there. It goes on your handlebars, and that switch not only allows you to turn the light on and off remotely, it has a USB charge port integrated in it, so you can keep your electronics topped off if you need to during the day, which means you can go on a bike trip and not have to worry about bringing your phone into the cafe with you, or charging your Garmin, or any of that crap. You don't have to stand in the bathroom at the campground. You can charge the camera that I'm recording this on will charge out of there. You can do just about anything that takes a small amount of USB draw. Just plug it in during the day. So I'll show you why I need to wreck this in just a second. This is the guts of a new version of this light. You can see here, cable, the remote, and you can tell as I wrestle with it here on camera. There comes the Ken Burns documentary. So you can tell that that cord's not very long. I think it might be 50 centimeters. Now, that's pretty short even if you're on a regular upright bike. If you mount that at the fork crown and you're tall, you may not get it out to the wide end of your handlebars. It's even worse for me because we were riding recumbents, and so this bike has a Luxos U on the front of it already, but this is back when Busch and Mueller made them with a long cable. And you can see that cable coming out here, the control cable, and it comes all the way back here and up these handlebars and around right here to the cockpit. This is the USB output here. You can see it's got that big fat end, and they give you a little rubber cap and it unscrews there so that when it's raining or whatever, you take that off so you don't ruin the thing. It's a good system. This one's long enough. They don't make them that long anymore. So if you're riding a recumbent, and that's what I'm installing these on, you can no longer have the switch on your handlebars. Or if you're riding a cargo bike, for instance, you want to get it out at the front of your rack. So this is a carbon fiber recumbent I made for my little girl, and you can see I put a new Luxos U on there, on that very shiny, nice, slick Sound Deluxe hub, and it's got the short cable. Now her boom isn't even out. You can see here that since she's still not that tall, the boom is all the way in still. And you can see that cable only reaches the middle of her steering mast there. Her hands are down there where her helmet goes. Now this isn't a complete tragedy for the time being because she can see that switch and reach down and operate it. It's not terrible here versus here. But on the next two of these that I'm making, that boom is going to be further out, and that switch may only be down here near the headset or something, which again wouldn't be the end of the world, but it's not really all that convenient. So my plan is to cut this cable, control cable, and insert a length of 4-strand wire in there in order to lengthen it. We'll talk about why that may or may not work. All right, with the camera balanced on my kitchen knife block, we'll take a look here. So brand new light. Always fun to take one of these apart. They just take a Torx head at the top to open up. And there are a couple of Torx screws here. This is, the top is metal. And it wasn't the other one anyway. The bottom is plastic. You might go, oh, isn't the whole thing metal? Well, you know, it would weigh a ton. So careful what you wish for, everybody. Plastic is a good material to make stuff from if it's treated properly. Same goes for carbon fiber, which is carbon reinforced plastic, right? So it comes apart pretty easily like this. The lens comes with it. And you see here a ribbon cable. My screws fell out. And right here, there are a couple of cache batteries. And on this side, you see where that control cable comes in. And if you just flip those cache batteries forward, you see that control cable comes in, loops around, and attaches to the board here. There's just a red, a green, a white, and a black. There's no shielding here. These are pretty thin wires. Not quite USB thin, but pretty thin. So I figured if I got some 4-strand control wire, that would do the job. I think that wire looks like it's about 24 gauge or something like that. Now here's the problem with this. The ASUB, which is a very good OEM manufacturer, which made the 2 of those colorful recumbents you saw in the garage, they said they tried already to lengthen one of these and that it didn't work, and that it made the light not work. And they had their electronics guy do it. Now they make a lot of electric bikes, so I think they know what they're doing. On the other hand, when I got a hold of Busch and Mueller, they said, yeah, go ahead and just lengthen it with 4-strand wire. And I know that you can have, here in the US, you can have the distributor put a new control wire on here. So it can't be that crazy. In other words, this board can't be so sensitive that it's really going to respond, I wouldn't think, to some minor difference in that cable. And if you solder those connections properly, that should work. Maybe the folks at ASUB shorted something in this board when they tried, like maybe they didn't unplug the battery, and maybe that when they cut the wire, maybe they arced something and shorted something in the board. I don't know. But to be safe, before I engage in this experiment, which might wreck this couple $100 light, I'm going to unplug the battery, which is here, and then go for cutting apart the cord. The battery has power and yellow. That probably goes to a thermistor, so that when it heats up, it tells the main board, hey, stop sending stuff, we're fully charged. So we'll go downstairs where my crappy workshop is, and we'll unplug that battery, and then we will try to cut and splice this cable and see if things work. So I am down here in the crappy workshop to get started on this project of potentially ruining a perfectly good headlight. I have in my stand a wheel I just made the other day with a sewn hub in it. You can give it a spin. You can hear the magnets that create the electricity. Those are the 2 spade connectors that send out the current, and we'll hook that up to the light when we get done, both before and after, to see how it works. Before we do that, I wanted to show you why we're gonna undo the batteries inside there. I put the light back together, which was not as easy as in the past. The main circuit board in the back is not sort of hot glued or attached in there in any way, and it was flopping all over the place, so it was actually hard for me to get the entire thing back together. Anyway, I'm going to hit the button on the light. You can do that here. See how I got a blue flash and then the light went? I get the same thing if I hit the back end. If I can get it. Well, it's in there. There you go. I hear a squeak. That lens is in there kind of loose. That's a flash mode that you can use just in traffic if the light's not on, to say, hey dude, pay attention to what's going on. If I hold it down, it turns the light on. Why is it operating? Those 2 little batteries I showed you in there have power, which is why I want to disconnect them before I cut this cord, so I don't have any circuit zipping anywhere where it shouldn't go and ruining the light. If I ruin the thing, I want to ruin it with as few variables as possible. So that's why I'm going to disconnect the battery before we do this job. I'm also going to check right now and make sure that everything is on the up and up when I connect it to that hub. All right, with the camera precariously balanced on top of a wafer vanilla roll can, turned upside down, I'm gonna quick hook this light up. I have a bunch of pigtails that I previously made for hooking up these lights. And geez, am I even gonna be able to do this? Do I have enough wiring? Well, this one here has the smallest spade connections on it, and those are the ones that hook into the spade connectors on the back of the light itself. There really is no positive and negative for this. They're marked that way, but what comes out of the hub is alternating current, so it doesn't really matter which you do for positive or negative. Now, this is actually, you can see here, I'm sort of struggling to get this hooked on. And that is the reason that I'm using these pigtails, because just the angle at which these are attached makes it tough to get past the bracket for the purposes of hooking the light on and off. So if you're going to be doing any messing with the light or the electricals, once it is on the bike, it'd be better to just have some pigtails. And I have attached some 2mm bullet connectors, like for RC cars, to these pigtails, so that I can attach wiring to those. These are a lot easier to manipulate than these little spade connectors underneath. So I'm going to fight with this off camera, and once I get it hooked up, then we'll demonstrate. All right, I got those on. More spade connectors. Is this going to focus? Hello. More spade connectors, slightly larger. These are the ones that go on the hub. And again, I'm going to wrestle with these. Get on there, you guys. Wow. Those two are bears. I'm not going to shove them all the way on at this point. They should have connection. And then you can see why I'm going to rely on these little bullet connectors instead, because look how easy it is to hook these up by comparison. So now we spin the wheel, we should see this light get brighter and darker. So we turn it on, and there it goes. Dim, bright, slows down. Rolls pretty well. Now it gets dim. That's the light sensing that it has stopped and going into stand light mode to save energy. This is actually a smart light that can tell when it's daylight. It can tell how fast you're going or not, and it arranges the beam accordingly. So it's a really good light. I hate to destroy it by what I'm about to do. Let's hope I'm not. So we know this light works. It's working properly right now. If I hold this in, or if I press this now, I get high beam, and I get the blue light here. Press it again, back to normal. Hold, it's off. So we know it's all working, control's working. So if it doesn't work after I do this, we'll know it was my fault, and we'll know what happened. All right, we've got my lousy little solder set up here. I've been practicing on small wires, and I've gotten to be a reasonably okay solderer. My biggest test, this is the actual control wire that I'll be using. Actually, well, there it is there again. That looks a little bit smaller than what's in the light, but it should be plenty to conduct as kind of the signal and 5 volts that are going to go through there. I actually took apart and put back together a USB cable, including the shielding, earlier last week, and it worked not only for charging but for data. So I felt like that was a test, because that's more difficult than what I'm doing here. So let's try to get things going. Okay, so I'm going to take this apart again, taking out these 2 Torx screws. I'm going to leave the pigtails on the back because they're holding on to the leads that are attached to that main circuit board, and they will help hold that circuit board in place. I may actually put a dab of hot glue on those sides of that thing just to kind of hold it in place, because when you take this thing apart, the experience isn't a real pleasure. Everything is sort of held together loosely, and getting it back together isn't easy. When you do this, you have to be super careful for a couple of things. One is that, remember this thing sitting out in front of your bike, potentially collecting rainwater. There are a couple of really tiny rubber washers that are on these Torx screws. I dropped one in my garage a week ago, and it took me half an hour to find the thing because they're transparent. So I'm going to put them in the little container that the light came in, and as long as I'm not a big enough idiot to spill that container, I should be okay. When you take this apart, you want to be careful not to scratch the lens. It's available as a replacement part, but maybe not so easily. You want to be really careful not to scratch or mar this plastic reflector, because that's what does the magic on this wonderful light beam. So I'm going to set those like way over on this other table and hopefully not ruin them. There's the guts of the device, and you can hear this kind of squeaking around. It's in there a little bit loose with sort of a, well, there's another PC, there's another board there, right? And here is the battery connection. These, by the way, are lithium phosphate cells. You cannot find these anywhere to replace, and Busch and Mueller won't send them to you either. Hopefully they last a long time. This battery chemistry is supposed to last a really long time, but if they don't, what you could do is just lengthen these cables, take the thermistor out, and lithium phosphate batteries of the same voltage are widely available in AA size to power like those in-ground garden lights, and you could, you know, piggyback a battery pack on top of the thing and just do it that way if you can't get a hold of these and they die. So I carefully unplugged the batteries. There were no locking tabs really. There's just a couple of little minor tabs on there that hold it in, so there wasn't any little trick to depressing it with a screwdriver or anything. I just carefully wiggled it out. So this board should have no power at this point. I'm going to set the batteries over there as well. And now, if I can, does that just flip up? I'd like to just flip up and get rid of this, but these two pieces, but I'm not going to bother. At this point, I think I'm actually going to screw it back together so that as I'm manipulating the cord, I don't scratch that lens or drop and rip that out or anything. I'm going to screw this back together so that when I'm cutting this cable and messing with it, I don't destroy any individual pieces of this that are flapping around. If you're wondering what happened to the light, I decided to wrap some scrap fabric that's sitting down here, because this is the sewing room, it's the everything room, around the light, and just taped it on so that I don't scuff this up while I'm screwing around with the cord. To figure out where to cut the cord, I am just going to double it, and I'm going to cut it about there. I am not going to just go at it with the cutters. It doesn't look like there's any shielding in there, but if there is, I want to be aware of it, and I would rather cut through this a strand at a time or take a look at what's going on as I'm going through rather than just bite the bullet. So I'm going to do that, then I'll come back and show the results. Well, I'm inside. It's kind of It's a weird wire, at least to me. I'm no electronics expert or veteran. I've got some basic skills. This thing is like full of powder in here. Almost like these were pulled through, or like an inner tube being pulled into a tire. You can see it on my fingers. There's no shielding in here. It's just a set of wires. And how big are they? I don't see anything on here, but I'm digging for my wire there. So the control wire I'm going to replace it with, the individual strands inside look like they're exactly the same size, and these are 24, AWD 24 inside my 4-strand. The housing isn't as thick. This is a pretty thick rubbery housing, but I'm not too worried about that. So I'm going to snip these, and then we're going to come back and put a ton of heat shrink on. All right, it's done. I ruined the thing. Hopefully not. I'm going to put, this is about 50 centimeters long. I'm going to put a meter of extra control cord in there. So I'm going to cut that off, start getting things put together, and then we'll try soldering it. So this, the wiggly one right now, is the control cable I'm going to add in the middle. This is the original, and you can see that. I stick them like that, we'll be able to see. Now, believe me, the this one is a tiny bit thinner overall. That's just because the housing isn't quite as thick. I think it's probably thick enough. I'm going to take this piece of tape that's bothering me. In both cases here, I'm actually going to use a lot of heat shrink tube on the outside. I'm going to insulate each individual strand inside, obviously, when I'm done soldering them. But I'm also going to put a piece of heat shrink tube that barely fits and a larger one on there, because I want to cover that whole bit very well, make sure it doesn't leak. But also, if it gets a little bit, the soldered points are going to be hard, right? I don't want to break them. So if I stiffen it up on the outside by having a little bit too much heat shrink tubing, that's fine with me. I was even thinking of reinforcing those with some carbon fiber rod hollow tube, but I think I'll skip that. So let's get things set up. All right, this is my additional cable that I'm putting in here. You can see that in addition to 4 wire strands, I've got some fiberglass to add tensile strength or something to the whole operation. So I'm going to snip that, snip this fuzz off. Can't snip the fuzz with those. Let's try with my shop scissors. All right, let's throw that away so we don't breathe that in. And these, by the way, I'm not an electronics guy, so I don't have fancy tools. I got this on Amazon for like $6. Pros Kit. It's got very small increments on it. I don't know if anyone can read those. This is 24, so I'll start with 22 because that might work. I'm gonna go for about not quite a centimeter. Yeah, it says 24. And snip, pull, and that's about how much I'm going to strip. And I'm just going to twist each one of these. The way I've been doing this, the simplest way for me to be able to do it and get it to conduct well and hold while I'm soldering it, has just been to twist them and then give each one a little hook like that, hook them together, and then go. Okay, so the way I do this, which may not be the right way or the best way, but it's the way I've figured out how to do, is I hook these little guys over. I've got them in my little alligator clip stand here, and I just kind of, once they're twisted together, I give them a pinch, and I try to get a little bit of tension on the alligator clips and the other wires out of the way, and try to get all the little stray hairs laying flat, and then I'm gonna get back here. Will it focus in the right spot here? Anyway, get that set up so that I'm ready to solder it. I'm going to heat up the soldering iron. When I come back, you can see I've got some heat shrink here for this. The trick here, I'm not a soldering expert, but in my experience, the trick here is to get this soldered as quickly as possible so you don't start melting all your insulation, and you don't heat up that wire all the way back here so that it shrinks your heat tape, that you can't get it over the spot. You want a good connection, but as little as possible solder. The way I'm going to accomplish that is this crummy Amazon soldering iron, which seems to work okay. I'll have to clean and retin that tip quickly. And when I come back, there's going to be some wind noise because I'm going to have a fan blowing because I don't want to breathe in rosin and solder. I will just be using some regular old school, man, what did I get this? Radio Shack rosin core solder. So after a quick wipe on my wet sponge, my tip looks decent. Phrasing? Are we still doing phrasing? My tip looks decent, and I'm going to make the very scary leap of trying to solder this little spot. I'm going to put a little tension on there, get those pieces like that. I'm going to turn the fan on. It's going to be loud. And then let's see if I can get this done, being a crummy novice solderer. See if this is hot enough over here on the sponge. Yep. Tip is tinning just fine over here. Smoke's arising. All right. Let's see what we can do here. Coming the kid and the dog down the stairs. All right. Took a little longer than I wanted, but I think that's a decent result. Let's see here. Is that gonna focus? Not bad. All right, I'm gonna take that off. You can see my heat shrink shrank down a little. We're cool. Can I get it over? All right, we're still good. All right. I got my heat gun next to me. I'm not going to show you that. I'm going to shrink that, then move on to the next. All right, green wire next. Make sure I've got my heat shrink tape there. If you forget that, it's hard to put it on afterwards. A tiny drop of solder on there to conduct the heat better into the wires. Come on, not doing great here. Oh, better. Okay, still melted the insulation a little more than I wanted, but it looks pretty well soldered. I'm gonna actually put on the super ugly, super huge magnifiers and take a closer look. Alright, time to try for the white wire. I seem to do better when I'm wearing the super ugly extra magnifiers. I didn't think that I'd be able to control my fingers better just because I could see things better down there. But I could. That one's by far the best one yet. I'm going to heat shrink it, come back and do the black wire. What sounds like a jet taking off is my air purifier deciding it doesn't like what it smells in here. So we're going to do the black wire here. and then heat shrink the whole wrap. A little bit pointy over there. I'm going to try to put a dab of solder on there. Alright, wipe off. A little bit sloppy, and we'll do the whole heat shrink. Alright, I've got the little individual wires heat shrank, however it goes. The trick now is to try and get them in as tight a bundle as you can, and then heat shrink over this whole extent. I've got a piece of heat shrink coming up from over on this side, and since this is cool, I'm going to see how far I can get it on there, and it actually goes quite a ways. So this is where the original stopped. I'm actually going to back it off, and I'm going to start out with the one from the other side, which I think will cover the entire span, and then I'm going to reinforce. So let's use this single piece. I'm going to shrink that on, and then I may put another piece in the middle, or run this up the side, or I may just leave it alone. I'm going to see how it goes after it's ugly and has heat shrunken upon it. Okay, ugly and lumpy, not unlike its creator, and cooling off now. I may just put this piece, will it even go? It may not. This piece won't squeeze over. I thought that might happen, and I just might have to cut it off, and I was fine with that. I've got a fatter piece here that will go and should shrink over that whole area, and I could trim it and just have it cover the part in the middle. I'm going to go ahead and just shrink that onto the center here. If I really feel like it's overkill, I can carefully peel it off later. Well, there we go. It might even be more ugly, but I think I'm pretty much done. So from at this point, got light leading to a, well, it's about 1¼ meters now. So now the next and last, hopefully, step will be to take the switch end and strip it and join it up the same way I did the first one. I'm not going to show you all that again. I'll show you the finished product. Okay, the other side is also finished. I like to think that the was done a little more neatly, but probably not. But good enough. I'm going to put the battery back in, and we'll see if this works. Now, I'll point out a couple of the cons here. The original cable is more flexible. The wires are a little more flexible than this. This is a little bit stiffer, but it's not bad, and it doesn't get moved a lot. Once you kind of zip tie it down to your steering mast, your handlebars, it's not going to get a lot of movement. So we'll need to be careful about these soldered joins that they don't get bent, snapped, ruined. But let's see if the thing even works. Or did I ruin a $120 or $220 light? Alright, I took off my fancy scrap fabric light cover, and just need to remove these top two Torx screws, and don't lose those little plastic washers. And we'll have it open again. comes off, and that top shield is held in with a couple of screws there. It's kind of loosely. We need to plug our batteries back in to get things going. So let's get those, and there's a little cross shape indentation, and these are just some foam bits that hold the batteries kind of in place inside under tension. There's a little cross shape on one of them. That means it's the battery that goes here. There's a little cross shape in the plastic. Because I paid attention before, and that was the way it worked. So that was because the batteries were upside down. This wire was toward the front bottom. That cross shape lined up there. So that's how they need to go. And we gotta get the wire in so they can do that. There's a little tab here. It lines up the wire harness with its little receptacle. And so I'm gonna get that lined up. Okay. It decided it wanted to work there. What happens if we press the button here? Oh my. Flashes. Hold it. It's on. Wow. Off. Well, it's not even all the way back together, but we know it worked. So that's great. I don't feel like I'm going to puke anymore. I will put this back together. Maybe I'll even video some of the struggle, because it isn't easy. We have to keep at it. Well, let's give it a try, see if we can do better. So the key to getting this done, I think, is to get this wiring harness, this one pushed kind of down into this slot, and sort of get the batteries so that they mostly stay out of your way. So there's a couple little plastic doohickeys in here, and this really is not very sophisticated. Everything is just kind of jammed in here and held by the tension of just being jammed in there. And try to get that battery wire tucked behind or alongside a little bit. This one down here. And we also need our reflector. And what's going to happen if we get this right is the reflector has two holes that line up with the holes into which those Torx screws go. And that is how it's all held together. So there's a certain amount of just kind of wiggling and pushing, seeing if it feels okay, and hoping for the best. And yes, we are doing phrasing. Definitely for that last bit. So that seems okay, however, it also seems not okay. Come on, you. I can see by looking in the top that I don't have it lined up properly yet. And that's probably because I don't have the pieces pushed in to the right spots. It's these little batteries. This is not a sophisticated design, as you can see. You just got rubber holding it in. Now I feel like I got fingerprints on there. I have a lens cloth here. You get a view of my ugly head while I clean that lens up a little and try to sort of force it where it needs to be. Alright. It's above those holes. Now if I can get this on and maybe. Yes, the lip is on the front. Feels like it sat down better in the back. Yeah, and we're all lined up. So we're good. Get one of these in here. Not going to crank it down too much. By the way, if you're riding in a ton of rain, you know, it might not be a terribly stupid idea to just press a bead of silicone caulk into those seams alongside. There is a drain hole in the bottom for any water that does get in. By the way, on these newer lights I noticed, I don't know if I can get a great shot of it here, underneath the positive spade connector, there's a hole. It's a vestigial hole because if you look at the circuit board on the back, which I did do, there's a couple of solder pads to put a positive and a negative lead, which would have powered the light. And on one of my other lights, one of those OEM ones, there's actually a pigtailed wire coming out. It's terminated, but that would have been a positive and negative that you could have hooked up to some other wires and run directly from the hub. These ones don't have that anymore, or maybe the OEM put it on, left it there for me. I don't know. I doubt they soldered the light. But anyway, the hole here in the casing is left for that. So if you really wanted, you could solder a wire to the pads, which are back up in here, and you'd have it. Now this is the main switch for the light that's not on the remote, so now that it's back together, we can test the light. We get our blue. If we hold it in, you get your orange status light. The light is working. By the way, if you have a properly connected tail light that is operating, you will get a little green on the side here to show you that your tail light is running, since when you're riding your bike you can't see that. So anyway, splicing this long control cord did not wreck the light, which is very cool because it means I can have the controller on my handlebars, and it's not that difficult to do. And to test the whole setup again, I hooked up connectors to the wheel, and we'll spin it. We're not getting anything. Flash, we get that. Hold it, turn it on. While the wheel's rolling, we get a brighter light until, and it dims. It gets bright again. We'll be good. One thing we won't be able to test, we can test it. You see the little red glow in there? That indicates that those little backup batteries inside here have enough charge for you to hook the USB dongle up and actually charge a device. Those buffer batteries not only power the light and the stand light, but they provide some buffer power so that when you're charging your USB device, and phones or other things can be kind of finicky if they're not getting constant voltage. They'll sort of start and stop their own charging. When the voltage drops just a little bit for a while because of, road conditions, or because you're going slowly uphill for a little bit, that buffer battery provides the difference for a while, and that red light is telling you that that's going on, that it's good to go with that. So another thing that shows is that this light came, those buffer batteries were pretty full of juice, because we haven't spun this thing enough to fill them, to put much energy in. When I spin this, that's probably equivalent to like 3 miles an hour for about 10 seconds. So anyway, you can lengthen these cables, take it apart carefully, unhook the battery, then solder your leads.